Good day, everyone. So today I will be discussing the topic about the solving problems involving ideal gas equations using the ideal gas law to solve real-world problems. So, these laws were combined and formulated into the ideal gas equation by Emily Clapeyron in 1834. However, it was Rudolf Clausius who later developed the kinetic theory of gases, which provides a molecular level explanation for behavior and ideal gases. The ideal gas equation was developed by combining several earlier gas laws including Boyle's law, Charles' law, and Avogadro's law. The ideal gas equation, also known as the ideal gas law, is a mathematical equation that describes the behavior of ideal gases. It is given by PV equals nRT. PV equals nRT. P is for pressure, V is for volume, N is for amount, R is the gas constant, and T is for temperature. This single equation connects the pressure, volume, temperature, and the amount of gas in moles. It can be rearranged depending on what to calculate, either N, V, P, or T variable. So the original equation is PV equals nRT. As I said, this equation can be rearranged depending on what variable is needed to calculate. If you are looking for the number of moles, N equals PV over RT. If volume, V equals nRT over P. If pressure, P equals nRT over B. And lastly, if temperature, T equals PV over nR. So for example 1, a tank contains 5 moles of nitrogen gas N2 and a pressure of 200,000 Pascal and a temperature of 300 Kelvin. What is the volume of the tank? So the given are N equals 5 mole, P equals 300,000 Pascal, T equals 300 Kelvin, and R is for the constant, which is 8.31. So our unknown is the V. So the equation that we are going to use is the volume. V equals nRT over P. So 5 mole times 8.31, the constant, and 300 Kelvin over 200,000 Pascal is equals to 0.062325. For example 2, a container holds 2 moles of oxygen gas at a volume of 0.1 meter cube and a temperature of 250 Kelvin. What is the temperature of the gas? So our unknown is the P, or the pressure. So our solution for this is P equals nRT over V. 2 mole times 8.31 times 250 over 0.1 is equals to 41,550 Pascal. For the last example, a balloon contains 1 mole of helium gas at a pressure of 100,000 Pascal and occupies a volume of 0.05 meter cube. What is the temperature of the gas? Our given is the N equals 1 mole, P equals 100,000 Pascal, V equals 0.05 meter cube, and R equals 8.31, and the unknown is the T. Our equation is T equals PV over nR. 1000 times 0.05 over 1 mole times 8.31 is equals to 601.8 Kelvin to the power of 7. And that's it for today. I hope you learned something. Thank you.